अब खुल गया आपका। आपकी आवाज नहीं आ रही है मैडम। अरे पकौड़े उकौड़े खा के बर्बाद कर दिया। अरे कुछ बोलिए, पढ़ाइए। हाँ, बंद करो।
Good afternoon, ma'am.
Good afternoon, ma'am.
वीडियो ना
ठीक है। तो देखो आगे बस। नहीं नहीं वो ठीक नहीं, आप बात करके देखो, आपको ऑडिबल होगी। मतलब आप नहीं बोल पाओगे, वो बोल करो जरा। हेलो।
हेलो
अब से ये आवाज आ रही है।
हमारी आ रही है।
हाँ धीरेन्द्र भैया।
हेलो
हाँ धीरेन्द्र
हाँ
भैया।
तमन्ना जी, मेरी आवाज आ रही है? हाँ ठीक। क्या हुआ अभी, आशीष जी नहीं जुड़े क्या? अच्छा
Good afternoon, everyone.
Students and researchers throughout the academic and professional journey. With these words,
Uh, Thank you, ma'am, for nice introduction of me. So, with a background of research, teaching, academia, as well as with currently working as a lead data scientist at Xelpmoc Design and Tech Limited. So, I'll be taking you through a little the AI, how AI can enhance the research, as well as especially one component of the research. As I did my uh, bachelor's, master's, and in PhD with respect to the computer science areas. And in the recent times, if you observe from the last 3 to 4 years of span, how the AI is revolutionizing the every area of education as well as research, healthcare. So as ma'am mentioned about the various sectors, how AI is completely transforming. And with these settings, like as a academician, as the faculty members, and as a research scholars, so we also should get updated with the latest technologies what is in AI, as well as to I worked with close more than a decade in engineering colleges in Hyderabad as assistant professor and associate professor, and with the research background. I know in colleges how the different kind of the research culture and the other activities associated in a college setting, like monitoring of the student performances, and the preparing the documentation for the various accreditation bodies, uh, like NBA, NAC, and making the students to prepare for the placements and the documentation. So there will be a huge kind of the different kind of scenarios, and the different things will be there. Along with all these things, parallelly, your motivation towards the research and continuing your research, like that is as a faculty member, our core thing is like teaching as well as conducting a research. So that should not fall behind getting updating with our like research career and publications in terms of that. So my next 30 to 40 minutes of time, I'll just focus on how the current era from the last 3 to 4 years of 3+ years of span, every one of we are using the technologies like the chat GPT. So this is more familiar, so I use that word. But other than that, there are so many other tools have come by the different companies have made available. Few of them are paid tools, few of them are openly available, and you can make use of them for certain period by paying certain amount. Like there are multiple tools are available, which helps to do, or those are the additional add-on tools it can be, which can be used for conducting a research in a little better way, because AI can't replace completely in research, but you can use these tools as a supplement to conduct research properly, as well as with all the additional loads what you get in your teaching, as well as if you are a scholar, PhD scholar, or a post graduation doing some kind of a research or the thesis. So balancing out all the other things like teaching versus the research part. So how you can make use of the tools available in the market, especially the AI tools, how you can like organize your research, and how you can make progress in terms of research. So that is a major agenda. With that, my talk will be majorly focusing on one aspect of the research part, that majorly I'll be talking about a literature study, because which is one of the important step in the field of like in conducting a research. So like whenever you are conducting any research, so why literature study matters, and especially as in our days, like when we are doing a research, like maybe at least 5 years back or 10 years back, if you see, if any new paper comes, how actually we are approaching, and how much time it is taking to read the paper, and how much time it was used to take for understanding that paper, so that you can make summary out of that paper, so that you can think through something, and you have to discuss with your supervisors. You will discuss if you are a supervisor, if you got some idea, you have to discuss with your research scholars and validate that idea. So there is long process goes on, and understanding, and then checking, validating your ideas and all. So this is a very time consuming process if you have seen just 5 years back. But now there are a lot of tools have in place which helps you to make use of these tools, quickly validate your ideas, quickly discuss or summarize your ideas, so that you can proceed to the next step. So with that intention, how AI is changing in the, especially in the literature study or in the entire research life cycle, like starts from your one step to the other step. So how AI is transforming, how you can make use of AI in your research life cycle, and then how you can adapt this deep research as a methodology to conduct your research, and especially the GPT kind of models, how to ask the proper question. So the prompting as a research skill, like whatever you are asking to the models, these are like some kind of a pattern recognition models. So whenever you are giving a right input or right question to these kind of models, these models will output you the right output what you are expecting. So how you can make use of these tools and technologies to, you can prompt in a much better way, so that those will give you a better output. And as these are tools are coming, so there is no replacement for the research, there is no replacement for the researcher. So how you can use these tools, and how you can verify, how you can balance out the ethics and the things in a research a domain, as well as in the research process, what are the things you have to follow. And then I'll show you a quick list of tools for each of the various steps in the research process. And if time permits, we can just quickly do a simple workflow demo, or I'll show you what are the tools are available. So this is the agenda for the next 30-40 minutes. So moving together, uh, why actually literature study matters. For example, as a researcher, if I want to start into a new research area, for example, as I'm a computer scientist or the data scientist. Yes, sir, any doubts? Oh, okay. Yeah, if you are a new PG students entering into a research domain with interest, or as a new faculty member like assistant professor, if you are entering, or you are already uh, a senior researcher in one domain like a mathematics or a physics or chemistry, but you want to, as the AI is becoming and the AI technologies are coming, you want to integrate those technologies into your domain, for example. So you want to know the other domains, how you are how impacting your domain. So you are not aware of those domains, but you want to know. But if these kind of things situations are there, so if you want to download the paper, read through the paper, understand, it is like very, very difficult. So to understand quickly what is happening in your domain with respect to the other one, like the literature matters a lot. So that's why like what is currently happening, and if you want to continue with that from that state to the next level, if you want to push that research, so you should understand what is the current status. Okay. And then properly you should identify what are the research gaps. For example, if you are formulating a particular research problem, where exactly the research is happening, where is the gap, so that you can identify the proper research gap, so that you can move or you can take your steps from then. And then you should identify what are the currently approaching techniques are there, what are the results we are getting, and how you can move or how you can improve the different techniques or hybrid approaches you can use, how you can move the like the baseline models for to the next level. So, and how you can give your justification to your work. All of these things are very, very important if you understand properly the literature. Otherwise, what happens if you have not done a proper literature study and you started working on like reading the paper and then writing the paper, and if you are submitting to the journal, so at the end, after waiting of 6 months or 1 year of time, the journal may communicate you like, because of some constraints, the or more comments you may receive, or the publication may get rejected. So instead of that, if you do as a pre-step, identifying what is a proper research gap, what is happening around in that particular research area, if you identify properly, so that helps you to formulate the problem properly, and then that helps you to minimize your research time, as well as at the end of 6 months of time, you won't get the rejection of the papers kind of thing. So that is a one important step as literature helps. And similarly, uh, why the traditional literature study is hard. For example, if you go back to 5 to 7 years back, or even 5 to 6 years back, if you go back, so there the challenge is like every day, like especially in our domain, like as I work in a data related stuff or data science related stuff, every day we get hundreds of papers or thousands of papers. If you consider one of the top conferences in AI, so for that conference, thousands of papers have been published, submitted. So even the published articles of one conference or 1 year conference, it takes months of time to read and understand, right? So, and even there are some kind of a seminal papers which you have to read and you have to understand everything. So the traditional way, if you start looking into the research articles and understanding them, it takes a quite long time to understand that paper. And then if one paper is talking about something and other paper is talking about some little variation of the study or some different approach, or on the same data multiple number of papers have been published, so in such cases, and there may be some connections between one paper to the other paper and one approach to the other paper, so making a note of these things and then approaching to a proper way, so it becomes very, very difficult. So this is an old school of the research style where these are the various challenges are there. So to handle all of these things, the AI, like especially the current era of, or as everybody are, we are living in an era of data and the artificial intelligence era. So where the tools which helps to read thousands of papers or hundreds of paper instantly. For example, if you, whenever you have observed, if you are using a GPT kind of tool for doing some kind of academic study or something, so internally, if you go through there, it will read different kind of web searches. It will do, it will look into the various kinds of PDF articles or the blog articles or the thing. And then it may be a very long documents also. It will quickly extract those information from each of the paper, and then it will prepare a nice summary of that. And then it will prepare you all the bullet important points, what are the things have been followed, or even if you are mentioning about, if you are looking into the paper, so there may be a few literature works will be there, citations will be there, and it will go into that particular citation paper and it will read that paper, come back, and then it will extract the whole summary will be prepared. So that is how the entire AI is changing the complete the research landscape. So that is where, as a faculty members and as a researchers, as a like the students who are interested in terms of like UG or PG students interested in conducting a research in various domains of your interest. So if you follow the latest what is happening around with respect to the AI and how you can adapt to that, so it will minimize your research time. And like, because AI making the publishing work and all of these things also very easily or very fast. And so if you are doing a traditional research, identifying idea, validate your idea, and then writing a paper, so by then the same idea may be published by other people or the fellow mates. Your idea may be a very super good idea, a very good methodology you are like preparing. But if you're not validating your idea, or if you're like not doing a very fast work, the same idea may be like by the time you start implementing and writing a paper, that idea, similar kind of idea, may get publication as an output by someone else. So that whatever the effort you are putting in may go waste. So like that, you have to make use of these tools, AI tools, so that you can fasten up your research work, right? So not only with respect to the literature study, so if you consider in the entire landscape of the research life cycle, like starts from the research question formulation. For example, if you are a budding researcher, or if you are like already a researcher, as I said, you are wanting to conduct a research in combination with a multi-domain or multidisciplinary research. So in a multidisciplinary research, incorporating like economics or like a business into the AI, business into the data, or mathematics or like physics and chemistry into some kind of like a biological sciences into the combination, right? So now if you see in a healthcare or agriculture or civil transportation, like what you see, the water resources, in all of these domains, now AI and data science is playing a very, very important role, as we know, right? So if you want to do these kind of things, so first you have to validate your research question. So whatever the research question you are trying to make it, whether that question is a valid research question which can sustain for at least 2 years of time for your research. Like nowadays, minimum of the or maximum a minimum of the research time, if you consider like as enrolling into PhD programs into for the junior researchers or something like, so that research idea should validate for at least for 2 to 3 years properly, so that you'll get a good publications and all for the who are trying to enroll into like a PhD programs kind of thing. Or else as a simple implementation or some kind of a research question you are preparing. So for that also you should identify, you should validate like refinement and then the problem refinement. So at the research question itself, you can validate whether the question is a properly, or you can iterate through, use through the tools, and then you can validate your idea. And after you validate your idea, and then you get proper strong literature you have to conduct. What are the different approaches exist currently, and what are the different methodologies, and then are any specific data sets or experimentation approaches, and what everything related to that, what are the other publications we have, what are the conferences are conducting, what are the other if it is an electronic kind of domain, what are the devices are there, like all sorts of things you have to do a proper literature, so that you get a clear picture of that problem, and then you can do. And similarly, when you are after you filter out your research paper, generally whenever you are coming to a research gap identification, or whenever you are formulating a problem, you may be downloading like 1,000 papers, maybe, or 500 papers. From that you read through. Generally in a traditional approach, what we do, we read through like introduction or the abstract and then conclusion. If you feel like these two sections are more relevant to your study, then you consider them as a inclusion criteria, and if those are not falling into your inclusion criteria, you discard them. So that is how we conducted research initially, like 10 years back, for example. So now these kind of very long process can be minimized. Simply you can screen the papers easily just by giving all of these paper titles and all to tools, which of them are relevant to this particular study and which of them are not relevant to a study. So after you identify set of papers, then you can use the deep reading and synthesis steps, where summarize all of these papers and concise prepare a very like a tabular kind of structure, where what is the approach has been used in each paper, what is the novelty, what is the remarks, what are the conclusions. So based on all of these things, you can prepare a proper, a solid gap identification. So what is the research gap we have, what is the thing, and which I can work on. And then other, like in terms of like experimentation, in terms of review and the preparing articles, there are so many tools are there at every step in the overall research life cycle. So many tools are there. Like even when you go for the publication, so you'll have like tools like LaTeX are there when you have to prepare the presentation or the research article suitable to a particular journal. And if papers will be accepted in journals and all with a specified plagiarism and specified constraints. So to reduce the, you have written all of the content manually and all, you have to check your grammar, you have to validate your plagiarism, all of these kind of things you have to do. If plagiarism goes beyond a particular stage, you have to minimize that plagiarism. So there are so many tools are there at writing level and in a experimentation level. For example, if you are doing research in like a civil engineering, like water resources engineering, like where you have to simulate some kind of a dam structure based on water flow kind of thing. So you have to estimate how much of energy is generating, and you have to simulate all of these. For these kind of experiments, you can't do construct a bridge and all, right? So you use some different kind of tools, like there is ANSYS is a one tool which you can design fluid dynamics, fluid mechanics, and everything you can incorporate into that tool. So that tools will give you some results and some visualizations and all. So that data you are going to incorporate into some other tool so that you do a lot of analysis. So like this, the tools will suggest, like if you are using a proper tool, it will help you to identify what are the things you can do and how you can improve your research productivity, right? So moving forward, like as these tools exist, and when you are talking, and as I said, like this will be majorly focusing on the literature aspect or the literature review as a process. How you can use the deep research, for example, if you go and look into the available tools or the existing tools, so how you can use the deep research as a tool to conduct the literature study. And how the deep research will treat as a literature study is like it's treat as a reasoning process and just not as an information retrieval. So when you go to like way back to 5 years or 10 years back, as we are using a Google, how do we use, like if you are having any question, just you go and search something and it will give you indexing all the different kind of websites, which of the websites are relevant for you, which of the websites are relevant or which of them are uh, relevant for you. So those will be coming as an output for your search query. But the deep research are with the help of these tools, so it won't give you just as an information retrieval or just based on your search criteria, it won't do. So what it will do is it will, whatever the proper question you are asking, if you are making a proper question and you are asking these tools, it will like go and search the what are the relevant documents it has to do, and it will prepare a verified summary, and it will look for the evidences. For example, if one of the document is claiming one sentence or one like output, so if any citations have been mentioned against that particular claim, it will go and look into that PPT whether that is a valid or not, something like. So all the time it may not be 100% correct, but it is much better than human spending weeks of time to validate that evidence, right? And similarly, it can use for multi-source comparisons. So like one paper or multiple number of papers you can put together, and you can compare what are the results you've been given by. And you can use for the hypothesis generation, like you are having some thought process in your mind to conduct some research. Whether that idea is correct or not, first writing idea itself is a very, very hectic thing. Like it will take weeks of time to prepare idea and then validate that idea. So the major capabilities how uh, deep research will help is like multi-document synthesis and the follow-up reasoning. So especially what happens in the current scenario with as we are like not with the scare of information or not with the lack of information, like the with the help of Google, with the help of all the available things, so much of information overloaded, right? If you go back to 10 years back or 15 years back, so that whatever you want to learn, whatever you want to read, so there is a very less amount of information were present. But now it's a too much information is available on the internet. But which information you have to consume is a best is a simple question, right? Whether I have to read this, whether I have to read this, whether I have to read this, which I have to read so that I can get, like if you don't identify proper document or proper thing, so then your entire like span of like you'll be wasting a lot of time in reading incorrect things.
Yeah.
Right, so that's where the concept of like follow-up reasoning, and then sometimes like the long context with like what happens in research is like, or in terms of like as a academicians and all, you may be like having some kind of accreditation processes, and also you do very seriously research for 1-2 months, and then because of the additional loads, maybe a personal constraints, family constraints, and maybe because of the examination duties or something, so you have to uh, keep aside for a month, a kind of thing, again you have to resume back to the research. So whatever the work you have done for a couple of months or couple of like 6 months of time, but because of the 1 week or 10 days or 1 month of gap, you will be missing a lot of things. But if you are using these kind of tools, what happens, whatever the earlier searching you have done, earlier discussions you had having with these kind of tools, so everything will be tracked and will be there in a memory, and from there you can continue and you can use them easily for the next subsequent steps of the research process, right? And then other additional features will have like inline citation tracking and automatic query expansion. So these are all additional field will becomes as a part of the uh, tools, right? So this is a simple slide to explain when you are comparing with the traditional literature study with AI search and then the deep search or deep research. So a traditional, like as what happens in Google search kind of thing. So you are going to read as keyword base, you are going to do a search and it will give you some results, multiple sources. Then what you have to do, you have to go read paper by paper. Then you have to do a manual comparison. Then you have to do approaches and everything you have to list out, and then you have to do a manual operation. So added like maybe a 5 years, 6 years back, if you see the AI kind of research where you can summarize quickly and do aggregate thing, but little faster comparison and with the tools and all. But now with the deep research thing, what is happening is with the one proper query, if you make a formulate and then if you give us an input, so it will take maybe a 10-15 minutes of time. But suppose to you are taking a 1 month or 2 months of time to read through all the papers, prepare summary. So it can make you to happen in 10-15 minutes of time. So likewise, it will do cross paper synthesis. It will do conduct evidence based, like it will compare the results across the different papers, and it will include the researcher also in the loop. For example, if you are giving some question, you are the question whatever you asked is not uh, there is some kind of an ambiguity exists in the question. It will prompt you to input some clarification on your question. Based on your input, again it will continue further in the research criteria and all. So that's where instead of only a tool, so researcher also comes into the loop where you can refine your search and then you can give a proper input so that the research process will happen faster and you can make use of these kind of tools, right? So as I said, like as we are talking about conducting you making use of this deep research as a tool, so the first and foremost thing is like as everybody is now started interacting with the tools like ChatGPT, Google Gemini, or Claude of Anthropic, or the different, there are n number of tools, or the different companies have released their own tools and all. Simply like whenever you are asking, like especially for the research thing, right? So these tools are basically a black box kind of tools which are based in pattern recognition and pattern recognition tools. So whenever you're asking a very simple question, it will give you, it may chance that it may hallucinate and it may give you some kind of incorrect results. And if you are asking a very proper structured question, it may give you a structured, a very proper output it may give, right? So just to illustrate, what I prepared is here like a prompting translate a research question into a structured reasoning task. Like here, what is exactly the reasoning here is like model has to take your input and it generates an output, it validates that output of the model, and it will keep improving on that further, and then it generates the final output, like how the human brains thinks for generating or for concluding some output, right? Similarly, these the tools will internally have some kind of a capability of that. So if you are giving a very basic prompt, like summarize, like I just chosen one healthcare domain, like or federated learning is a one kind of a machine learning technique. So summarize papers and federated learning, this is a very basic or very naive, vague prompt. So that the LLMs or the like the ChatGPT kind of tool may give some kind of the hallucinated output. For example, if you are giving a little detailed prompt, that is summarize the recent papers on federated learning for imaging, medical imaging, it may go little into that particular domain, and for the medical imaging it may search. If I'm giving a very detailed prompt, like this is a even not very detailed, I'll show you some examples of that. Identify peer reviewed and preprint studies, like I'm specifying a specific constraints, like a peer reviewed is a constraint, preprint is a constraint on some specific domain, and then compare what are the various things like architectures, data sets, evaluation metrics, reported performances, limitations, and present rules in a structured table with a verified citations. So for example, if the same task, if I'm giving 3 different prompts, okay, so ultimately I'm going to get a better results. For example, the same, if you are giving this as an input to the ChatGPT kind of tool, it may take maximum of 5 to 10 minutes, and it will nicely read through majority of the papers which are published in the year, like for the 6 years of this duration, and then it will give you a nice output in a structured table with all these headings, like what is the architecture they have used, what is the data set they have used, what are the evaluation metrics, what is the reported performance. So all of these things nicely it organizes into a tabular kind of thing. It will show you an output. Sorry. Okay, so when it comes to using these tools, so all the tools you can't depend directly, like you can't believe 100% correct, right? So even when you're looking into the outputs of each of the tools, there will be some kind of a disclaimer, that is like the output generated by these tools may be incorrect output, right? So everything is like, it is not completely, these tools are not replacing the AI, or these tools are not replacing completely the research aspect. These tools are not replacing the researcher. These tools works as a supplement or add-on tools to conduct your research faster. So then what you have to do is you have to do a proper verification, like cross check the citation. For example, if the model is giving, or the output you generated with, like the citation is already generated, or the DOI, or when you year, all the paper publications, whatever it is citing or conducting the literature study. So you have to verify these things. Okay, verify randomly maybe 5 to 10 in a list of like 50, 60. If you have a time, you can verify each of them, because when you are sending that for the publication and all, so you have to verify everything. So then validate the data sets and the other reported metric. But in a particular domain or particular area, so there will be some seminal papers which you have to read 100%, then you can understand completely the picture of them. So you have to read those seminal papers without missing each and every line, and then confirm the claims from the original sources. Like if any paper is giving citations from other papers and this is narrated in that particular article, so you have to cross verify those papers or those things, then you have to use them. Otherwise, what happens if you are just copy pasting, and then if you are sending for the publication and all, so sometimes it may be a risky process. And then other risks are hallucinated and incorrect citations also possible, because these the tools whatever are there in the market, so those are majority of the tools are best pattern recognizers only. So when there is some kind of a pattern is found, so it will generate output. So how do you validate that? So you have to verify, and with that verification only you can minimize the wrong or the incorrect outputs. And over generated summaries will be there, and missing seminal or the closed work access will be there. So these few of them will be missed, but you have to verify and use that. And then so ethical uses, like you have to use as an assistive, not as a complete. You should not give the handover all of your research research work to the AI tool itself. So it should help as your assistant, or it should just help you. Those tools should help you in only assisting you or conducting your research of in a faster way, right? So other things are like use AI for exploration and synthesis, use the human judgment for the interpretation, and like wherever you have some kind of a personal touch should not be missed, and you have to use those tools. And these are the few tools, like as everybody familiar with the chat GPT, I'm sure, and then perplexity, Gemini, Claude, and especially for the uh, literature study. So these are the few other tools like semantic scholar. Like I just opened all of these tools, which of the other tools what we have. So semantic scholar is a one kind of a tool where like it searches. These are the so many number of papers are there in their database, and if you are searching for any specific like a paper, for example, if I'm searching for some paper title, so which was actually one of the seminal paper in the field of like AI, so which is having almost 1,62,000 citations. So like you'll get a lot of papers, and then you can this is like simply like a Google Scholar kind of platform where you can have like a keyword based and semantically, like you'll have all the details here, abstract, and then you'll have additional information will be there, so you can get the citation format. This is very similar to your Google Scholar. And then this is a connected papers, like if you use the same title, so like here it will search with a similar kind of thing. You can generate, if you log in, and then you'll be able to see the connected papers, like from one paper to the other paper, what are the citations you have. It will build a nice graph, a pictorial representation, so you can navigate to each of the paper and you can understand. So this is a little paid, like, and for the 5 graphs per month you can generate for free. For example, if you are doing a for one work, if you want to do a literature study, so you can use like monthly 5 times you can use this free, and then you can generate like a nice pictorial representation of all of the graphs for a particular paper what you are looking for. And similarly, there are other papers like a Research Rabbit. So Research Rabbit is also like, for example, if I'm searching for this paper, so here so you can organize the different kind of projects you can create here, and then you can create the library, and then you can make use of. So you're like, for example, if you are taking all the relevant papers are there, so here what happens here is like how each paper is been connected to each other paper. So it will create a nice graphical pictorial representation. You can add the papers, and then you can connect. So all these sorts of things, there are multiple tools are available. Like similarly, the consensus is another tool. Few of them are paid tools are there, but you can make use for certain thing. Like here, this is a similar thing, like it will generate a similar GPT kind of thing. So for example, if you want to just read through each of the papers separately, what are the conclusions? So each paper, if you see, just you'll get what is their abstract. And the snapshot of the very clear, like very quickly, you'll be able to understand like what is that paper is talking about in a very short time. Like reading through the entire thing is very difficult. Like, so you can just quickly look into this paper, and then what are the papers we have, like that you can quickly do. So this is like very big list of the tools are there. So what I did is like I just summarized based on functionality of the tool. So that is like a deep discovery, like in the initial phases of the thing, how what paper, what tools you can use, like semantic scholar, perplexity, consensus, and literature mapping, like Research Rabbit and connected papers. These are used for how you can connect, how the papers are connected each other. And then this is also helps us to connect the papers. Consensus also helps us to understand which paper is referring to which paper and understanding that. And there are other tools, like if you are very long PDFs are there and you want to ask some questions on a PDF, like these days, if you see the papers, research papers are coming hundreds of pages with their appendix with their additional things and all. So you can make use of the additional tools to question that PDF and then make use of that. So this is a one prompt quickly I want to show. Like for example, if you are making a similar thing, I think I've prepared one. So here in this ChatGPT, you have various options, like you can go to a deep research mode and you can give this question, for example. So it will ask, like for the clarification, it will be putting into the loop of the researcher, like you want only peer reviewed papers, journals or conferences. Is there any specific range? And then are there medical or what kind of thing you want to have? So then if you give like some 2020 to 24, so it will take a couple of minutes of time. So from these 4 years of time and federated learning for the medical image, so you can see here. So on the right side, you can see like what is happening, how it is searching. So it is taking the articles from nature.com. So few limitations will be like, it may be few of the articles may be behind the payment walls or the payment gateway. So those can't be accessed anyway. As a human also, you have to go and see the subscribe for them and get the papers, but openly accessible majority of the papers which are openly accessible available. So mostly those papers like LCBR, Science Direct and PubMed and Science Directs dot like LCV01. So it searching, like it searches as a web tool, intelligent tool to dig into all of these various possible sources, extracts all the valuable or more relevant papers to that, and it will prepare a nice summary of that. And if you are asking to prepare a tabular format, so I just did before that showing you, I just did this query. So I just generated last night about these are the things like output from the deep research mode is for this, like it, this is a table output it generated. For example, if you want to look into this paper and what is the methodology they have approached, what is the data set they have used, what is the size, and then what is their conclusions they are writing. So if you want to see all of these things, reading each paper, just assume that it's one day, for example. So reading through almost 10-15 papers, it takes 10 to 15 days of time or even more, right? So if you just look in here, like maybe by end of our presentation, it will complete looking into almost, it identified 21 sources. And from these 21 sources, it will collect all of this data and it will prepare nice tabular representation of the a summary. Okay, so this is few more additional possible prompts I'm mentioning here, how you can make use of this. And then a few limitations using this is like the hallucination. Sometimes the model, if you are asking a very niche area, very specialized domain, if you are asking, or as I said, like the papers may be behind the payment gateways and all, so these will not be get accessible. And then some kind of methodological limitations will be there. And then few may be biased towards frequently cited papers. For example, there may be a few papers, seminal papers, everybody is citing. So because of the citation count and all, so those the models also may be biased, and that may be giving or more extra weightage to those kind of research papers to pull the information and give you output. And then some, like in lot of journals and all nowadays, so they have integrated into okay. So integrated into these tools like plagiarism detection, AI text detection, these things are there. So we should be very careful, like using this text in writing, so we can minimize this AI text in research articles and all. So these are the additionally whatever the additional tools which I found we can help in the research papers or writing and conducting a research. So with this, I conclude like AI will not replace the complete researchers, but the researchers who use AI with responsibly will shape the future of the scholarship and the research. So a special thanks to Naushad sir and Xelpmoc Design and Tech Limited for giving this opportunity, and the college for inviting me for delivering this session. Thank you. Thank you, ma'am.
इंतजार कर रहे हैं।
आप देखिए
कहाँ लिखूंगा? देखो यहाँ बैठे आ रहा है ना?
मन्ना जी बाहर कहिए, प्राचार्य जी आ गए हैं।
जी देखिए, सम्मानित शिक्षकों, शिक्षिकाओं एवं छात्र छात्राओं, जो वर्तमान युग है तकनीकी प्रधान युग है। हम लोग जानते हैं कि जो देश तकनीकी रूप से जितना आगे है वह देश उतना ही विकसित है। और तकनीकी में एआई एक नया प्रयोग है जो पिछले 2-3 वर्षों से प्रचलन में आया है, और हम लोग देख रहे हैं कि जिस ज्ञान के लिए, जिस सूचना के लिए हम लोग बहुत सारे प्रयत्न करते थे, बहुत आसानी से हमें वो सूचनाएं उपलब्ध हो जा रही हैं, और सूचना ही नहीं उपलब्ध हो जा रही, हम वहां पे विमर्श कर रहे हैं एआई के साथ, और नई प्रकार की सूचनाएं, क्या उचित है क्या अनुचित है। गूगल पर तो हम जो सूचनाएं हैं उसी को प्राप्त करते हैं, लेकिन एआई उससे भी आगे काम कर रहा है। और अभी सूचना मिली है कि केरला और असम जैसे राज्यों में सरकार ने एआई के माध्यम से टीचिंग करने का निर्णय लिया। तो निरंतर एआई का प्रयोग बढ़ रहा है। अगर हम 30-40 वर्ष पहले जाते हैं तो जो पहले की तकनीकी 1000 वर्ष पहले की तकनीकी थी, 2000-3000 साल पहले की तकनीकी थी, वो लगभग 1500-1600 ईस्वी के आसपास तक चली। एक ही तरह की तकनीकी, और तकनीकी विकास से ही आर्थिक विकास होता है, सामाजिक विकास होता है, नए प्रकार की राजनीतिक धारणाओं की उत्पत्ति होती है। इसलिए विश्व में जितनी विचारधाराएं आज प्रचलित हैं, वो औद्योगिक क्रांति के बाद जब मोड ऑफ प्रोडक्शन, उत्पादन का तरीका बदला, तो नई नई विचारधाराएं भी आई, समाज भी बदला, और जो सामाजिक संबंध, आर्थिक संबंध और राजनीतिक संबंध थे, वो तकनीकी के साथ बदली। आज हम सामाजिक संबंधों में भी बदलाव देख रहे हैं। वो तकनीकी विकास का उत्पाद है। तो एआई के सहयोग से जीवन का कोई भी ऐसा क्षेत्र नहीं है जो अछूता है। और रिसर्च में जब हम डाटा कलेक्ट करते थे या कोई काम करते थे तो कितनी मेहनत हम करते थे, लेकिन अब एआई के मदद से, क्योंकि मैं तो मानविकी का विद्यार्थी हूं, और हम लोग एआई की सहायता से जो समस्याएं होती हैं उसको देख रहे हैं। लेकिन जो विज्ञान के लोग हैं, जैसे आईआईटी के प्रोफेसर अर्नब भट्टाचार्य का एक लेक्चर हो रहा था, मैं भी था, तो उन्होंने कहा कि अगले 10 वर्षों में लगता है कि हमारी भी नौकरी चली जाएगी, इसलिए कि एआई इतनी तेजी से विकसित हो रहा, इतनी तेजी से काम कर रहा। एक उनका भाव था कि एआई किस तरीके से काम कर रहा है, किस तरीके से बढ़ रहा है। अभी कुछ समस्याएं एआई के साथ आ रही हैं, लेकिन अभी तो शुरुआत है। अगले 4-5 सालों में ऐसा लग रहा है कि एआई बहुत जगहों पे एआई आ जाएगा। तो बहुत लोग चिंतित हैं, कहते हैं कि नौकरियां चली जाएंगी। बात यह है कि कुल उत्पादन देश का कितना हो रहा है। अगर जीडीपी में एआई की भूमिका हो रही है, अगर एआई ही उत्पादन कर रहा है, चाहे इंडस्ट्रियल सेक्टर में, चाहे सर्विस सेक्टर में, चाहे एग्रीकल्चर सेक्टर में, उत्पादन से मतलब है कि कुल किसी देश का जो उत्पादन हो रहा है अगर बढ़ रहा है, किसी से भी बढ़ रहा हो, हमको तो उपभोग करना है। कम परिश्रम में हमको चीजें मिल जाए तो वो भी अच्छा है, तो घबराने की आवश्यकता नहीं है। और जो आज बात हो रही है रिसर्च पर, तो रिसर्च भी निसंदेह बहुत तेजी के साथ आगे बढ़ेगा। जिस प्रोसेस को करने में हम कई साल लगा देते थे, जिन डाटा को कलेक्ट करने में, लैब में प्रयोग करते थे, अब बहुत आसानी से सब चीजें हो जाएंगी। जो 2 साल का 3 साल का काम था वो 2-3 महीने में हो जाएगा। तो हम लोग एडवांस स्तर पर काम कर सकते हैं, आगे काम कर सकते हैं। समय बचेगा तो और आगे हम सोचेंगे। धन्यवाद। इसी के साथ मैं अपनी बात को विराम देता हूं। धन्यवाद। अभी आई पे हम क्या बोलेंगे?
Thank you so much, Dr. Tamanna, for the very kind introduction. It's a pleasure to present in front of all of you, faculty, PhD students, and other scholars. I hope I'm audible, like the clarity is fine. Okay.
Yes, sir.
Great. So I was asked to present on the role of AI in modern scientific research. It's a pretty broad area. So I thought of picking a subtopic, like a sub area on which to focus my talk today. I'll just present my screen to get started. Right. So is my screen visible? The presentation. Okay. Okay. Excellent. I thought of focusing on a rather curious, interesting, and novel area, which is quite nascent. It's a new area of research, which is using LLMs to simulate human decision making. It's pretty curious. I'm personally curious about this topic, but is it even possible? Does it make any sense? And I hope that many of you will form a view about this, even though you may initially be skeptical by the end of the talk. So this is actually sort of like an investigation into computational social science. In other words, the overlap between AI and social science. So how can AI be used to perform experimental social science research? So in particular, in today's talk, we will explore this question, which is, can LLMs, large language models such as ChatGPT, Claude, etc., can they mimic human decision making? Okay, so in particular, we will explore two questions. The first question is, do LLMs have the potential to replace the utility maximizing agent in economics, which is also called Homo economicus? So the whole foundation of theoretical economics is based on the notion of this utility maximizing agent. Essentially, it's a mathematical attempt or approach to model human behavior. And I'll get into more details in the next few slides. But can we use LLMs to potentially replace this mathematical approach? So that is the first angle that we will dive into. The second angle is the following question. Can LLMs simulate the behavior of multiple human subjects in social science experiments? Okay, so as you know, like social sciences such as sociology, social psychology, behavioral economics, a big chunk of that research actually focuses on field experiments, which is experiments with real human participants. So now that LLMs can answer questions just like human beings, so you type in something and it will answer just like a human, a very natural question arises that, can we do field experiments with LLMs instead of with humans? And how well does that work? Okay, so if these two questions have positive answers, in other words, the answer to both the questions is yes, then LLMs have the potential to make a major methodological impact on social sciences, in particular social sciences such as behavioral economics and social psychology. So that is the agenda. I understand that many members of the audience are not from the social sciences. They may be from hard sciences or humanities or other subjects. But I hope that the talk will still be interesting for you, because we all live in a society and it doesn't hurt to understand our fellow human beings better, their thought processes and their behaviors. So I hope this will be interesting to everyone. Okay. The first paper that we will cover is this paper called Homo silicus. Okay, so it's by this professor at MIT called Horton, and it's published very recently in 2023, and it has 749 citations. Not bad for a new paper, which is just 2 years old. And therefore, I thought of reading it, and I personally found it very interesting. So I hope I can share my excitement with you as well. So to begin with, maybe why don't we try reading the abstract? So what is it all about? It's like a summary of the whole paper. So here goes. So newly developed large language models, these are like ChatGPT-like models, because of how they are trained and designed, are implicit computational models of humans, a Homo silicus. Now, what the hell is silicus? What does the word silicus even mean? Well, it comes from the term in silico. Okay, so in silico refers to experiments, simulations, or analyses performed on a computer. So it comes from the word silicon. So from silicon, we get silico, and from in silico, we get silicus. So using computational methods, so these are experiments using computational methods like AI, machine learning, and modeling, often in biology, medicine, and drug discovery. This is an alternative or a complement, not a substitute, but a complement to physical lab work, which is often called in vitro, or living organisms, which is often called in vivo. So that's what in silico means, and that's where Homo silicus, that term, comes from. So if some of you are economics students, you will have some idea of how decision making is modeled in economics. So LLMs can be used, just like economists use Homo economicus. So in economics, there's this notion of a representative agent, typically modeled with one utility function, which models human preferences, which is the basis of human choices. So this Homo economicus, this mathematical function, and I'll show a diagram to explain this a little better in the next few slides, but this Homo economicus is usually given some sort of endowment. It could be money or some stock of goods that they own already. They're typically given information, they are given preferences through that utility function, which I was talking about, and so on. And then after giving it these things, we then try to see what is their behavior in that circumstance. So in economics, it's almost like building a toy model of an economy with one or more of these representative agents. These agents are called Homo economicus. Now, can we replace that mathematical approach with a large language model? In other words, can we ask a large language model such as ChatGPT or Claude to role play a human being, saying, hey, put on the hat of a human being and look, I'm going to give you a situation. What type of choices will you make? So that is the premise of this paper. And what this author Horton has done is that he has tried to replicate 4 papers from earlier behavioral economics literature. So behavioral economics is like at the intersection of psychology and economics. And what this field tries to do is that it tries to take into account the fact that human beings are often emotional. Human beings often have cognitive biases. Human beings are not always purely rational creatures which behave exactly according to like a mathematical function, such as utility function. And so that field relies very heavily on experimentation with real human subjects. So these 4 papers, which Horton is referring to, these 4 papers are like Charnes and Rabin, Kahneman, Knetch and Thaler, Samuelson and Zackhausen, and then one paper of his own he'll refer to. So these 4 papers essentially are also experimental papers. So they are lab experiments done with real human subjects. And we'll see, each of them is rather intriguing. We'll take a look at each of these in detail. But the idea of this talk is to go through some of these results and see what happens if we try to replace the humans with LLMs. Does that even work? Does that make sense? Do the LLMs respond in a manner similar to real human subjects? So that's this paper by Horton. And here's the key idea. So I think a little bit I already talked about, which is, most economics research takes one of 2 forms. The first question it asks is, what would this ideal representative agent, this Homo economicus, do in a particular situation? And the second is more empirical in nature. So this empirical line of thinking is asking this question: what did Homo sapiens actually do? So of course, this is like intersecting with statistics. So this is like collecting data, either primary data through a lab experiment, or non-experimental, like secondary kind of data, and analyzing that to see what human beings actually do. So the type A research takes a maintained model of humans, like it's called Homo economicus, and subjects it to various economic scenarios. So I'll just try to, maybe for those who are not familiar with economics at all, I'll just try to show a little diagram. So here, this is Homo economicus. This is an agent which maximizes a simple utility function. I mean, at the undergraduate level, this is the model people usually start with, the students, which is only 2 goods. In reality, this is n goods. Like as you take more advanced courses in economics, these models are generalized to go from 2 all the way up to n. And here's a budget constraint. So M represents income. P1 is the price of good 1. X1 is the quantity of good 1. P2 is the price of good 2. X2 is the quantity of good 2. So the preferences of this agent are modeled using this utility function. So this is a mathematical representation, this kind of a projection of the utility function on the x1, x2 plane. And typically, the premise is, there's this budget constraint line, which is representing the maximum amount of money the guy has, the agent has. So any combination of P1, X1 and P2, X2 always adds up to M, which represents this line. It's a negatively sloped line. If you rearrange terms and if you plot X2 as a function of X1, you'll see that it's a negatively sloped line. And then the optimal choice is the maximum amount the agent could buy. So that's basically this point at which the indifference curve is a tangent to this constraint line. So that's the equilibrium, so to speak. And then what happens is that economists do these types of experiments. What happens if the price of one of the products changes? So this is depicting that situation, that maybe the agent was dividing his money between consumption and charity, personal consumption and charity. And then maybe the price of charity went down. So this line was a little steep and it became flatter. So the optimal choice changed from E prime to E. Okay, so more amount of money was spent on charity. Or maybe it was the other way around. Initially, charity was cheap, but charity became more expensive. So the optimal choice showed that now the agent is spending less amount on charity. Depends on which point is a starting point. So that's the simplest example I could give of the classical paradigm, Homo economicus, which is kind of the cornerstone. It is the framework used by economists to model almost everything. And then the premise of this paper is that, hey, can we replace this approach? So can we replace this mathematical function with just prompting a language model, saying, hey, look, language model, this is your income, this is the price of good 1, this is the price of good 2. How much of good 1 and good 2 would you buy? Please role play a human being. So that is Homo silicus, the Homo silicus approach. Okay, so that's the key idea. And what we'll do is we'll now go through those 4 papers which we mentioned. So remember I said Horton himself has gone through 4 papers, paper 1, paper 2, paper 3, and a 4th paper of his own. And don't worry, these papers don't really require any prerequisite knowledge. I've deliberately chosen the material so that everyone can understand. So Kahneman, right? Kahneman is a Nobel laureate. He won the Nobel Prize for his work in behavioral economics. And in 1986, he wrote a paper, the topic of which was standards of fairness. So what was the paper all about? Let's just read a little bit, and we can take it a little slow if that's okay. So these were experiments motivated by Kahneman. So Horton has done some experiments trying to replicate what Kahneman did in 1986. So what did Kahneman do? He did a simple thing, a very simple thing, nothing fancy, which is just a survey. So he collected survey responses to economic scenarios. So one example is that subjects are told to imagine a hardware store which raises the price of snow shovels following a snowstorm, which is opportunistic behavior, right? Like if you see, oh, there's a thunderstorm and you are selling if you're selling umbrellas, would you raise the price of umbrellas? Is that fair or unfair? That's the question being asked. So all the respondents in the survey simply gave a binary response that they thought, oh, it's fair or it's unfair. Now, keep in mind, there is no right or wrong answer. This is empirical research, which is trying to capture how people think. The audience, like humans at large, how do they think? Do they feel something is fair or unfair? So what this experimenter does with LLMs is that instead of asking humans, he asks a model called GPT-3. Okay, so he asks, he gives the same situation to GPT-3 and says that, look, this hardware store has raised the amount it charges for snow shovels. Do you think it is fair or unfair? But also it asks the GPT-3 model to role play a human. It says that, hey, can you play the role of a left-leaning person? Can you play the role of a right-leaning person? Basically a liberal versus a conservative, which is a political leaning. And there are certain other variations he does. And it tries to capture whether the response, in other words, the answer of whether something was fair or unfair, depends on the role you ask the LLM to play. If you ask them to play a left-leaning person, is their answer different compared to if you ask them to play a right-leaning person? So in general, the LLM responds very similarly to human beings. So price gouging is just a term which means charging excessively high prices for essential goods and services, especially during crises like natural disasters or pandemics, when demand surges and supply drops. So imagine during COVID, somebody charges like 1 lakh rupees for an oxygen cylinder. Is that good behavior or bad behavior? Is that fair or unfair? So same type of question, basically. So this is the original paper by Kahneman. I've just taken a screenshot. We don't really need to read it, but it's there in case somebody wants to refer after the talk. And this is the experimental setup which Horton has done. So Horton has given this prompt to GPT-3 saying, look, a hardware store has been selling snow shovels for $15. The morning after a large snowstorm, the store raises the price to $20. Please rate this action as number 1, completely fair, number 2, acceptable, number 3, unfair, number 4, very unfair. So in the original paper, which is Kahneman's paper, 82% of respondents reported either unfair or very unfair. Okay. Now, what does the LLM respond? So what he's done is he's created some variations in the experiment, meaning there are 2 ways he framed the situation to the LLM. One is using neutral language, like changes the price to is neutral language. On the other hand, raises the price to is sort of suggestive language that, oh, raising the price, doing something negative. So he's captured whether the LLM's response varies on this framing as well. So this framing, changes the price to versus raises the price to. And finally, he's also asked the LLM to like put on a political value hat, like a political leaning hat, socialist versus libertarian. Libertarian is like right wing. In India, it would be like BJP. Socialist would be CPIM, Communist Party of India. So results. Okay. So it looks a little complicated, but don't worry, we'll go through it slowly. And we'll try to first look at the x-axis and the y-axis. So on the x-axis, we have three types of responses. Acceptable on the left side, unfair in the middle, very unfair on the right side. Okay. And on the y-axis, we have counts of answers. So for example, this kind of stacking, okay, means that all the time the respondent replied this, whereas this type of stacking, which is the red box next to the gray box, means that sometimes the response was unfair and sometimes the response was very unfair. Okay, so that's what the y-axis is capturing. Now, these boxes, these are called facets. So here, what we are doing is we are giving different situation to the LLM. So here we are saying price has been raised from $15 to only $16 after the snowstorm. Is it okay to raise the price by $1? Here we are saying $15 to $20. So the price has been raised by $5. Here we are saying $15 to $40. And here we are saying $15 to $100. Okay. And finally, these boxes capture the political leaning, the political stance that we've asked the LLM to adopt. Here we have said that, hey, please adopt a socialist stance, here a leftist stance, here a liberal stance, here a moderate stance, here a conservative stance, here a libertarian stance. So 6 different stances. These terms are a bit US kind of American kind of terms, but like in India also there's a pro-BJP, pro-Congress, pro-CPL, different sort of political stances people may have. So what do the results look like? So we can pick one of them. See, for the socialist ones, even if the price was raised by just $1 from 15 to 16, the LLM said, oh, unfair, you know. And if it was raised by $5, it said very unfair, half the time, unfair half the time. On the other hand, if you asked it to adopt a stance of moderate or libertarian is like somebody who totally believes in the free market, then just a $1 increase, the LLM said it's acceptable, not a problem. The store has the right to do that. And if you increased it by $5, it's still said acceptable. However, when the price was increased for $15 to $40, it said, no, now it's unfair. Even though I'm a libertarian, it's still unfair. Like, this is too much. You can't raise the price by that much. And similarly for $15 to $100. So the results very much mimic what humans did in Kahneman's original 1986 paper. Keep in mind, this sort of table of results is from the LLMs, GPT-3. But the structure of the results very much matches what humans did in the survey responses of the original Kahneman 1986 paper. So that, I think this is interesting. So far we are seeing that, oh, LLMs respond very similarly to humans. Okay, moving on to another one. So there was a paper by Samuelson and Zeckhauser. Okay, so this is not the famous Paul Samuelson, who's the Nobel laureate. It's his son, William Samuelson, who's also like a good economist, a famous economist. So this domain is also behavioral economics, but now the topic that is being investigated is something called status quo bias. Now, what the hell is that? Well, let's see what Horton has written. So, okay, so the respondent is being asked to allocate a federal budget. Okay, so of course, resources are limited. There's not unlimited budget. So there's a trade-off. If you allocate budget to this, you have less budget to allocate to that. So the respondent, in this case, the experiment respondent or the survey respondent, has to allocate a federal budget between highway safety and car safety. The original paper showed that humans are subject to a status quo bias. See, status quo bias means that if they know that the current allocation is 70 to highway safety and 30% to car safety, they will prefer to stick to the status quo. They will say that, okay, that's fine. Don't have to change anything. However, if you tell them that it's the other way around, that, hey, 70% of the budget is being allocated to car safety and only 30% to highway safety, the status quo bias is like, oh, that's also fine. Whatever is the current state, I'm fine with that. So that is status quo bias. Now the question is, do LLMs also suffer from status quo bias? Okay, so he replicates the result of the original Samuelson-Zeckhauser paper by endowing AI agents. These are LLMs, same GPT-3 model, with baseline views about the relative importance of car highway safety, and then he puts those agents through different scenarios, with each allocation taking a turn as the status quo. Okay, so concretely, I'll jump into the sort of the experimental setup, which will explain this part a little bit better. But this is the original paper of Samuelson-Zeckhauser, which had human respondents. Okay, and this is the experimental setup. So what he's done is that he's asked GPT-3 to reply to this sort of a base prompt. The National Highway Safety Commission is deciding how to allocate its budget between two safety research programs: improving automobile safety, which is bumpers, body, gas tank configuration, seat belts, and improving the safety of interstate highways, which is guardrails, grading, highway interchanges, and implementing selectively reduced speed limits. Now, subjects were then asked to choose their most preferred funding allocation. So 70% budget to cars, 30% budget to highways, or 40-60, or 30-70, which means 30% allocation to cars, 70% to highways, or 50-50. And the substantive outcomes are the same across scenarios. Okay. Let's take a look at the next part. To detect status quo bias, we need to see if the agents respond differently when a funding scenario is presented as a status quo, which is the current situation. However, I specifically need a range of choices with a neutral framing for this result. I can then show how preferences change under the status quo framing. All right, so these are the options. These are the results. Let's take a look. Here you see these are the responses, and this is sort of the percentage of subjects. So you can view this as a bar graph, and the responses are 30% car, 70% highway is one option, which is this leftmost option in each of these figures. Then the other one is 50% car, 50% highway. Then the other option is 60% car, 40% highway. And finally, 70% car, 30% highway. Okay. So this color of either white or red is indicating what was told to the LLM is the status quo. Okay. So here we told the LLM that the status quo is 30% auto. Okay. And you see, when it got to know that the status quo is 30% auto, majority of the time, LLM chose the status quo, which is why this bar is the tallest bar. Here, we told the LLM that 50% auto is the status quo. So when the LLM got to know that, oh, the status quo is 50% auto, it decided to stick to the status quo. It did not decide to choose any other option. This is exactly what human beings also did in a lab experiment setup, in an experimental setup. Here, we told the LLM that, oh, the status quo is 60% car, 40% highway. So it picked the status quo option. And here we told the LLM 70% auto is the status quo. So it stuck to the status quo. By the way, you may be wondering, if you did not tell it the status quo at all, what would it do? In other words, neutral framing, where you ask it to make a choice without telling it anything about the status quo. In such a case, most of the time, the LLM picked 50% car, 50% highway, which is sort of the safe option. like if you don't know which way to go, like as Buddha said, if you don't know which path to take the middle path. So that's what the LLM did here. Now, Okay, moving on to the third paper. I'll just zoom out a bit because I've been like rambling on and on. Is everyone with me? Like, are we like uh, any questions so far? Is there anything I can clarify so far? I can continue. Okay, great. Awesome. So, okay, so the next paper is a paper by Horton himself, and this investigates price floors and employer preferences. Okay, so price floor in the context of hiring is basically a wage floor, like a minimum wage. Okay, so what he wrote in his original paper 2023, this was with a field experiment, that when employers face a minimum wage, they tend to substitute towards higher wage workers. So imagine that you are owning a restaurant and you're trying to buy the services of a dishwasher, like a human dishwasher. So you're trying to hire a dishwasher, and then you face some application, you get some applications from lower wage employees and some applications from higher wage employees who are demanding a higher wage. Normally, if there is no minimum wage, people like human participants tend to hire the lower wage employee. They try not to hire the higher wage employee. But when a minimum wage is imposed by the government, they move away and they say, hey, now there's a minimum wage anyway, like I have to pay so much, so let me spend a little bit extra and get a more experienced candidate who is demanding a higher wage. So the attempt is to replicate that result with LLMs and see what happens. So this is the original paper by Horton, Price Flows and Employer Preferences. This is like experimental evidence from a minimum wage experiment. And this is the current experimental setup, which is with LLMs. Okay, so here the author creates a scenario where an employee selects from a pool of applicants that differ in their experience and wage asks. So the scenario I create is a person hiring for the role of dishwasher. The hiring manager is also told that the typical wage is $12 per hour. Okay, so the AI is asked to select an applicant. I can then observe the hired worker's wages and experience level of the hired worker. Okay, so this is the prompt which is given to GPT-3. You are hiring for the role of dishwasher. The typical hourly rate is $12. You have two candidates. Person one has 1 year of experience in this role and requests $17 per hour. Person two has 0 years of experience in this role and requests $13 per hour. So person two has a lower wage ask, but also has no experience, whereas person one has a higher wage ask, but has 1 year of experience. So who would you hire? You have to pick one. Okay. So the author then measured the responses of GPT-3 and he created a job level data set. And what he did is he took two dependent variables. One is hired worker wage, and the second is hired worker experience. And he did a single variable linear regression. So he regressed these two dependent variables on a single independent variable, which is the minimum wage indicator. Okay, and table one reports the results. So if any of you have done any sort of regression, you might know how to interpret such a table, but essentially this is showing the coefficient, which is if the dependent variable is the wage and the independent variable is the minimum wage imposed, what was the like the coefficient of the wage vis-a-vis the minimum wage? So essentially the derivative or the partial derivative. Yes, sorry. And this is the constant term in a linear regression. These are the p-values. And we can see that based on the p-values, this is significant. In other words, if a minimum wage was imposed, this coefficient was significant and it's a positive coefficient. In other words, the LLM ended up hiring the more expensive worker, not the cheaper worker. If this was negative or zero, it would have been, oh, like he didn't hire the more expensive worker, but it's a positive coefficient. So there was, in fact, a statistically significant effect from the imposition of the minimum wage to the workers' actual wage, which the LLM was willing to give. And similarly, you can see that the same with experience. So when a minimum wage was imposed, the LLM ended up hiring the more experienced candidate. So again, like experimental results, which were with human subjects in the original 2023 paper, were replicated with LLM subjects, and we got extremely similar results. I'm going to skip this one. Because this table is a little complicated, and I may not have the time to cover this, but the slides are available. If you want, you can go through it. And I'm going to skip ahead to another paper, which is in the area of social science using AI. So this is using AI for mostly behavioral psychology, but of course the learnings can be applied to other social sciences as well. So let's see. This one is also very interesting. So this is by Gati Ahar. She's actually a PhD student. She's not yet gotten her PhD. So this is a very good paper. 905 citations as a PhD student is very impressive. So, right. So what is the key idea? So in Alan Turing's original imitation game, an AI system was used to simulate a single individual well enough to fool a human judge. The language models may come close to winning this game in the near future, because, like, conversations with ChatGPT are almost human-like. Most of the time, you don't know whether it's an AI responding or human responding. Now, that was called the Turing test, or the Turing imitation game. Now, these papers suggest a new type of concept, which they call a Turing experiment. What the hell is a Turing experiment? So Turing experiment evaluates an AI system in terms of its use in simulating human behavior in the context of a specific human subject study. The key difference is this, that unlike a Turing test, which uses an AI model to simulate to mimic the behavior of a single human, a Turing experiment uses an AI model to simulate the behavior of multiple subjects. That's the key difference. Multiple subjects. So it basically asks the AI to role play different people. Maybe in America, it could be a young black male. It could be a middle-aged white female. It could be old Latino female, and so on. So it tries to ask the AI to role play these different demographic groups, and then it creates a sample of multiple LLM responses, AI responses, where the AI is role playing a different type of human being. And that kind of experiment is called a Turing experiment, because powering these agents inside is sitting an LLM. So that's the idea. So here, this kind of study has been done in social psychology, linguistics, behavioral economics. And formally, there are two types of inputs to each Turing experiment. First are the participant details, which might include names, it might include occupational information. So blue collar, white collar, farmer, person working in manufacturing industry, driver, that could be occupational information. Other demographic details, like I mentioned, age, gender. And the second type of input is optional experimental conditions, which may include relevant setting details and other stimuli. So, and the output is recorded as a synthetic record. Okay, so why don't we take a concrete example? So here's one sort of attempt to do a Turing experiment, replicating an original paper of Kath et al. In 1982. So Kath et al. In 1982, they did a very interesting study in experimental economics. And the topic is relative payoffs and fairness. Like, if two people get unequal payoffs, like, does one person reject the payoff, saying, mujhe chahiye nahi chahiye, jane do. So this is basically the ultimatum game, sorry. So this in this paper, Gath et al. Set it up like this. There were two types of players. One was called the proposer, and the other was called the responder. So the proposer is given an amount of money and has to decide how to split it between himself and the responder. Okay. So imagine I am given a certain amount of money, 100 rupees, and I have to split it between myself and Dr. Naveen. That is the situation. And the responder, in this case, it might be Dr. Naveen, either accepts the take it or leave it proposal, or he rejects it, saying, oh, I think this is unfair, I don't want the money. Now, the original Homo economicus view tells that, oh, some money is better than no money. So always the responder should accept the money, because otherwise he's not getting anything. Even 1 rupee is better than 0 rupees. But in reality, what we found, like rather what Gath et al. Found in 1982, is that humans are, they have these notions of fairness. And if they find that a situation is unfair, they'll walk away from it, even if that means sacrificing money, which is throwing money away or leaving money at the table. So what happens if we give the same experimental setup to LLMs? Do they behave in a similar manner to human beings? So this is the original paper, the 1983 paper, just a screenshot. And I'll move on to the experimental setup. Okay, so this is the setup. In this setup, the ultimatum game simulator takes 3 inputs. First is an integer offer in the range of 0 to 10. So either $0, $1, all the way up to $10. There's a name of the proposer, and then there's a name of the responder. The offer corresponds to an initial endowment fixed at $10 and 11 possible offers. And out of, they play around with different name combinations and all, like Mr., Mrs., etc. And I'll just read out the prompt because this explains the whole situation. So this is the prompt which was given to a language model, I think GPT-3 again. In the following scenario, Mrs. Huang had to decide whether to accept or reject the proposal. Mr. Wagner, who's the proposer, is given $10. And Mr. Wagner will propose how to split the money between himself and Miss Huang. Then Miss Huang will decide whether to accept or reject Mr. Wagner's proposal. If Miss Huang accepts, then Mr. Wagner and Miss Huang get the money as they agreed to split it. For example, if out of 10 rupees, I say, hey, Naveen, I'm keeping 7 for myself and you keep 3, and Naveen accepts it, then I get 7, he gets 3. However, if Mr. Huang rejects, then nobody gets anything. So if I say, hey, 7, 3, let's split the money that way, and Naveen says, no, Samdip, I'm not okay with that, then neither of us will get any money. Okay, so that's the setup. What happens? These are the results. And here, well, the authors found some strange results with one language model called LM1, which is a very small model, which behaved very weirdly. So let us ignore this blue line, because these small models are often not complex enough to behave like human beings. It's the larger models which actually end up behaving like human beings. So this is the offer size out of 10 on the x-axis. So I can either make an offer of $0, $2, $4, $6, all the way up to $10. And on the y-axis, we are plotting the percentage of time the offer was accepted, which can be thought of as a probability. So this is showing the relative frequency or the probability of acceptance. So we see that as the offer tended towards 5, which is equal allocation, right? 5 is equal allocation between person 1, person 2. The probability of acceptance went up to 1, but any offer which was below 5 was rejected a percentage of the time. And in fact, if the offer was close to 0, let's say $1 or $2, very seldom was it accepted. And the orange line shows the data pattern observed with LLM subjects, and these black dots shows the data pattern observed with human subjects. And there were 2 separate human studies. Both, if we plot it, we see that, oh, the orange line and the black line are very close to each other, almost as if LLMs do the same thing that human beings do. All right. I'll just do a couple more and then I'm done. I think I have about five or seven more minutes. So this is a very famous experiment done in 1963. It's in the area of social psychology, and the topic is obedience. Okay, so instead of reading this out, I'll actually play a 2-minute video which will explain the experimental setup, and then I'll show you the LLM results. So this is the experimental setup, just a 2-minute video. Oh, sorry, I think I'll have to unplug my earbud so that everyone can hear. Oh, I'm sorry. So, can you hear now? Is it आवाज आ रही है? Oh, one second. Acha, okay. So in that case, what I will do is I'll read it out because this is like plain. I'll read out the experiment setup so that people can understand. This is the original paper, Milgram, 1963, and this is the experiment setup. So what they did is that they said that, oh look, this is a memory study, but actually it was not a memory study. They hired some actors and they hired some other people to listen to some instructions. So the other people were outside and the actors were inside this like glass box, and they were given questions that, hey, I'm going to ask you a question, and if you can answer the question correctly, you'll be given a reward, or